Hello student, today we are going to discuss about how we find the inverse of any matrix using Gauss elimination method and Gauss-Jordan method. First we discuss about is a theoretical aspect of how we find inverse of a matrix using Gauss elimination method or Gauss-Jordan methods. So let us discuss about how we find the inverse of a matrix using Gauss elimination method or Gauss-Jordan method. Suppose as we know that we able to find out the inverse of any matrix if that matrix is a non-singular matrix. So here we assume that let A equal A be any non-singular matrix. A be any non-singular matrix, and here we write A equal A11, A12, A13, A21, A22, A23, A31, A32, A33. For sake of simplicity, here we consider 3 cross 3 square matrix, and here we assume that A is a non-singular matrix. Let A be a non-singular matrix, singular matrix. Now we try to find out the inverse of this matrix using the Gauss elimination method, then Gauss-Jordan method. So here let A be a non-singular matrix and A inverse equal x11, x12, x13, x21, x22, x23, x31, x32, x33 with the inverse of the matrix A, and here we write and A inverse with the inverse of matrix A. Now what is our aim? Our aim is to find out the values of x11, x12, x13, x21, x22, x23, x31, x32, x33. If we find these values with the help of a Gauss elimination method, then this method become inverse of a matrix using a Gauss elimination method. If we find these values x11 means all the values of our matrix A inverse, all the element of a matrix A inverse by Gauss-Jordan method, then this become a inverse of a matrix by Gauss-Jordan methods. Now how we find this one? Here we are going to use the one property of a inverse of a matrix and that particular matrix. As we know that this one is a very simple property, means if we multiply A into A inverse, then this become what? This become a identity matrix. As we know that A inverse equal I. Now here we write A matrix A means A11, A12, A13, A21, A22, A23, A31, A32, A33. This one is a matrix A. Then we find then we write a matrix A inverse. A inverse is what? x11, x12, x13, x21, x22, x23, x31, x32, x33. This one equal identity matrix of order 3. This one is a 1 0 0 0 1 0 0, 0, 1, 0, 0, 1. If we closely observe this expression, suppose this one is a equation number 1, then if we multiply a11, a12, a13 by first column, similarly second row by the first column, third row by the first column, then we find a system of a linear equation. System of a linear equation, unknown is a x11, x21, x31. If we multiply the first row by the second column, second row by the second column, third row by the second column, then we find a second system of a linear equation. First row by the third column, second row by the third column, third row by the third column, then we find a third system of a linear equation. Means we factorize this one into a 3 system of a linear equation. In a first system of a linear equation, unknown with the x11, x21, x31, x12. In a second system of linear equation, unknown with the x12, x22, x32, and in a third system of a linear equation, unknown with the x13, x23, and x33. So in a next page, and what is the right hand side? In a first system of a linear equation, right hand side, the value of a right hand side with a 1, 0, 0. In a second system of a linear equation, right hand side with a 0, 1, 0, and third system of a linear equation, right hand side with a 0, 0, 1. Now we write all these 3 system of a linear equation. So first system of a linear equation become what? a11, a12, a13, a21, a22, a23, a31, a32, a33, and what are the unknowns? Unknown with the values of a first column of a inverse matrix. So this one is a x11, x21, x31. This one equal first column of a identity matrix. This one is a 1, 0, 0. This one is a first system of a linear equation. Suppose this one is a equation number 2. This one is a system of a linear equation. Second system of a linear equation is a a11, a12, a13, a21, a22, a23, a31, a32, a33, and what are the unknown for the second system of a linear equation? Second column of a inverse, x12, x22, x32. This one equal second column of a unit matrix 0, 1, 0. So this one is equation number 3. Similarly, third system of a linear equation is a a11, a12, a13, a21, a22, a23, a31, a32, a33 multiplied by third column of a inverse, x13, x23, and x33, and this one right hand side is a third column of a unit matrix 0, 0, 1. This one is equation number 4. Now by solving the equation number 2, means a system of a linear equation second, system of a linear equation third, system of a linear equation 4, if we solve this system of a linear equation to find out the values of a first column of a inverse, second column of a inverse, third column of a inverse by Gauss elimination method, then we say that we able to find out the inverse of a matrix using a Gauss elimination method. And if we find the values of a first column, second column, and third column of a inverse, which are the unknown of a first system of a linear equation, second system of a linear equation, third system of a linear equation by Gauss-Jordan method, then we say that we able to find out the inverse of a matrix A with the help of a Gauss-Jordan methods. So here, in order to find out in order to find the values of column vector of A inverse using Gauss elimination method, or by Gauss-Jordan method. So, how we find the solution? Either by the Gauss elimination method or Gauss-Jordan methods. So, now our aim is to find out the solution of a system of a linear equation second, system of a linear equation third, system of a linear equation 4 by the Gauss elimination method or by the Gauss-Jordan methods. So, in a Gauss elimination method, what is our aim? Our aim is to convert the coefficient matrix, suppose this one is a coefficient matrix here A, into a upper triangular matrix. So, in each system of a linear equation, we perform a same operation to convert the matrix A into upper triangular matrix, because matrix A is same in all the system of a linear equation in a second, third and fourth. So, rather than to solve separately all the system of a linear equation, here we try to solve simultaneously all the system of a linear equation. For this one, first of all we write the augmented system. Rather than augmented matrix, here we write a augmented system. Augmented system of a system of a linear equation, of set of a system of a linear equation, system of linear equation. So, how we write a system of augmented system rather than augmented matrix? In augmented matrix, we write a matrix A and the right hand side means A partition matrix B. But here we write what? Here we write a matrix A, then partition, then matrix I, because I is a what? First column of I is a right hand side values of a first system of a linear equation, second column is a right hand side of a third system of a linear equation, means a second system of linear equation, and third column is a right hand side of a third system of a linear equation. So, here we write a system of a augmented system, and augmented system become A11, A12, A13, A21, A22, A23, A31, A32, A33, and partition, and here we write a unit matrix, means 1 0 0 0 1 0 0 0 1. And if we try to find out the inverse using the Gauss elimination method, then we convert this matrix A into a upper triangular matrix, and we try to solve if we try to find out the inverse with the help of a Gauss-Jordan method, then we convert the matrix A into a diagonal matrix. So, now to find out the inverse, inverse using Gauss elimination method, Gauss elimination method, Gauss elimination method, Gauss elimination method, we convert, we reduced the above augmented system, augmented system as follows. So this one converted into like this one, means there is no change in the first row, A11, A12, A13, and here we convert this one 0. There is a change in a one time, A22 dash, A23 dash, and here there is a change in a two times, A33 double dash, and also here we modified the values of there is a something else. Suppose here we write values, means P, Q, R, S, T, U, V, W, X. So after converting this one, then we write a reduced system of a linear equation, then we find the values of unknowns. And to find out the inverse using the Gauss-Jordan method, so in order to find the inverse using Gauss-Jordan method, we reduce the augmented system as follows. Means this one converted into a 1 0 0 0 1 0 0 0 1 partition, and suppose this one is a P Q R S T U V W X. So as we know that in our Gauss-Jordan method, these values be the solution, means a PS be the solution, ATV W be the solution, RUX be the solution. These are the constant. So we may say directly, means without solving the system of a linear equation, we may say directly this one is a what? This one is a A inverse. But in a Gauss elimination method, there is a need of a back substitution to find out the values of an unknown, but in a Gauss-Jordan method, there is no need of a back substitution. Directly we able to find out the solution, means this one is a solution of a, this one is a value of a what? This one is a value of a what? This one is a value of a x11, x21, x31, this one is a value of, and this one is a value of a what? This one is a value of a x12, x22 and x32, and this one is a value of a x13, x23 and x33. Okay. So this one is a B, how we find the inverse of a matrix using the Gauss elimination method or Gauss-Jordan method. So what is the summary? If any matrix is a given, then we write we assume that A inverse is a inverse of a matrix A, then we write a system of a linear equation, then again we partition the system of a means using the property A inverse equal I into a different system of set of a system of linear equation. Then we solve a set of system of linear equation by Gauss elimination method or by the Gauss Jordan method. Now